Welcome to Ask and Learn.
Hello and welcome to this video solution of numerator. Here we are given that a small block of mass small m is kept on a bigger block of mass capital M, which is attached to a vertical spring of constant k. So here we have a spring, and over which we have a bigger block of mass capital M, and above which we have the small mass m, right? And the system oscillates vertically. So now we have to calculate the resultant force on the smaller block when it is displaced through a distance of x above this equilibrium point. Now the whole system is moved upwards. So let's say the bigger block moves here, right? And the distance between the extension is x. Now we have to calculate the forces on the resultant force on the smaller block, right? Now considering, let me draw the smaller block separately. Now here the forces acting will be the weight mg acting downwards, right? The reaction force R, or the normal force N, between these two blocks will act upwards, and at the highest point it will move. The overall acceleration will be A, or the net force will be towards down, right? This we can say, from this we can say that the net force is given by this force F, which is equal to mass times the acceleration of the block, right? Now acceleration of the block can be calculated as m omega square x. Fine. And now you have to calculate what is the angular frequency of the system, which is equal to root over of k by m, right? K by total mass. Here we will have m plus m. This gives us equal to m k x over capital M plus small m. So this is the first answer, that is the overall the resulting force on the smaller mass. Next we have part B. Here you have to calculate normal force on the smaller block at this position. Okay, so here we have the normal force, so we can write the net force F equal to the mass the weight minus the normal reaction. This gives us normal reaction equal to mg minus F. Now we plug in the value of F. We have, let's say we take m common from here, so here g minus kx over capital M plus m, right? So this is the normal force on this smaller block. Next we have a separate part C. Here you have to calculate the maximum amplitude with which the two blocks will oscillate together. Here we have to calculate, we'll write the net expression. So here we have the normal reaction equal to mg minus F, right? And at the highest point, to oscillate with both the mass to oscillate together, we will have the normal reaction equal to 0 at the highest point. Okay, n equal to 0 at highest point. This gives us mg equal to F, right? So F we can write mg, so g minus kx by m plus m. Now here we see that kx by mg m plus m equal to 0. So here you have to for the both the blocks to reach the highest point and move together, we have to have the maximum normal force towards 0. That means the normal force should be smallest. Now we have n equal to mg minus f equal to kx m by m plus m, right? And now for the normal force to be the smallest, this force has to be greatest, right? That means the amplitude should be maximum at x. So we can see the amplitude of this oscillation will be equal to x. I hope this is clear to you and have a very good rest of the day. Thank you.